All right, you have in front of you 9.5, maximizing the volume of a cylinder. Last warning. Question to start it off. What do Coca-Cola, ginger ale, Five Alive, and tonic water have in common?
They're fizzy.
They give you cavities.
They are all come packaged in aluminum cans. They are cylinders. Okay.
Wait, tonic water does not come in that.
Sure does.
Like a Pierre. Did you know
Perrier?
there's new commercial?
Different.
Did you say Pierre?
Investigation. How can we compare the volumes of cylinders with the same surface area? So we've been doing this with rectangles. We've been doing this with square-based prisms. Now we're going to do the exact same thing with cylinders. We're given a surface area. Okay, your task is to design a cylindrical juice can that uses no more than 375 squared centimeters of aluminum. So you're given the maximum surface area you're allowed to use. What do we want to do? We want to create a cylinder that maximizes volume, that has the greatest capacity possible using 375 square centimeters. So do you think it's going to be a cylinder that looks like this?
No.
Do you think it's going to be a cylinder that looks like this?
No.
Yes.
Or do you think it's going to be a cylinder that looks like this?
No.
Actually,
Okay.
yes.
Assuming they all have the same surface area. Alright, let's figure it out. Now, this is a little bit tricky. Jaden, stop turning around backwards. Thanks very much. This is a little bit tricky because the formula is a little bit more difficult. So in order to calculate surface area, what variables do we need to know? Surface area of a cylinder. The surface area of a cylinder
It's 2 pi r plus 2 pi r h.
close.
It's
It's pi r squared for one circle, right? Because it has two circular bases. So it's got pi r squared once, twice. Okay? Then it has this rectangular wraparound. And we already have learned, we figured that out. That's basically just the circumference of the circle, which would be 2 pi r, times the height of the can. Okay? So there's our formula for the surface area of a cylinder.
Is this under one?
So what, sure, just write this under 1. And what variables do we need to know in order to use this? What variables are in the formula, guys?
We need R.
We need to know R. What
and
else?
H.
And H. So the surface area of a cylinder is based on R and H. It's based on the radius of the base and the height of the cylinder. Okay. In order to investigate, I'm reading from number 2. In order to investigate our options, we're going to choose cylinders that have different radii. So maybe a radius of 2, then a radius of 3, then a radius of 4. Okay? In order to calculate the surface area of each cylinder, we'll need to know the height and how the height changes with respect to radius. Think about this. As the radius increases, what's going to happen to the height?
Height will increase. No. Decrease.
Because surface area is always going to be the same. As the radius increases, height will decrease. Please write that in your blank. Okay, the height will decrease in order to use the same amount of aluminum.
Oh, so it'll get like squashed down and spread.
That's right. So as the height increases, it'll get skinnier. The radius will shrink. As the radius grows, to use the same amount of surface area, the bases will take up more area, but the rectangular wrap will take up less area. Okay? So it's either going to be tall and skinny, short and fat, or somewhere in between.
somewhere where it's tall and fast.
So we're going to develop a formula that relates the height to the radius. Okay? Because we're going to change the radius. We're going to say, okay, this one has a radius of 1, a radius of 2, a radius of 3. But in order to find the actual surface area and volume, we need to have the height. Okay? So here we go. We're starting with this surface area formula. So you're going to have to write a little bit small in that next section. Okay, you've got surface area equals 2 pi r squared plus 2 pi r h. And this is going to be a lot of algebra, so make sure you're paying attention. In our investigation, we are given the surface area that we're allowed to use. What's the surface area that we're allowed to use?
375.
375. If you're not paying attention, please start paying attention now. So we sub that in. Okay? 375 equals 2 pi r squared plus 2 pi r h. Now, we are trying to isolate h. Okay? We're trying to get h by itself on one side and everything else on the other side. So the first thing I see is this doesn't have any h's in it. So I'm going to go ahead and subtract this from both sides. Okay? So I'm going to subtract that from both sides. It's going to give me, on the left side, it's going to give me 375 minus 2 pi r squared. And on the right hand side, I'm just going to be left with 2 pi r h. All I did was subtract this amount from the right side and from the left side. Alright, well now I have this h over here, and it's attached by multiplication to 2 pi r. So how can I detach them? I can divide both sides by 2 pi r. Okay? So on the left, I have 375 minus 2 pi r squared divided by 2 pi r. And on the right, what am I left with?
Equals h.
Just h. I'm going to flip that around so that I have h on the left. 375 minus 2 pi r squared over 2 pi r on the right.
This is
All we did was use very simple algebra. We added and subtracted to both sides, and then we divided. It was 2 steps. Okay? You need to be able to do this. If you can't do this, if your mind is still blown, then you need to go back to Unit 1 and 2 and 3 and review. Okay? You have your EQAO on the 6th. That's your big test for all Ontario, or maybe even, yeah, it's all Ontario math test. And it's worth 10% of your overall grade in this course.
What?
Okay? Good. Let's finish out our investigate. A question about this specifically.
Yes.
Okay.
So, with that now, so can you cancel out the 2 pi r and the 2 pi r, or is the squared symbol not allowing that?
The only reason I can't cancel out 2 pi and 2 pi, or r and r, is because this is not by itself. It's in a group with 375. Okay? If there was a pi in this term and in that term, then I could cancel out all the pi's. Yeah? If this was divisible by 2, I could divide this by 2, this by 2, this by 2, and that would cancel out the 2's.
So that's the answer. We don't have to solve it.
This is a formula that has been rearranged to express h in terms of r. So now if I know the radius of my cylinder, Sam, in fraction, it's like 6 times so far that you're not paying attention. Stay paying attention. It's difficult stuff. Pay attention. Now if I know the radius of my cylinder, I can find the height. And if I know the radius and the height, I can calculate surface area and volume.
So this would
Okay?
be if you have what?
If you're given the radius, you can find the height. The
So-
only things in here are r and h. The rest is just numbers.
So it would always be like you would always have the same number as like 375.
No, in
always
this
use that
case,
number?
we're given the surface area.
Oh, I see.
Yeah, the surface area is 375.
Oh.
Okay, that's what we subbed in right in the first step. Anyway, it doesn't matter. Now we're going to use this formula to complete our investigation. Okay? So the investigation says, now use the table to record the data on different shaped cylinders. So you can see how the radius is given. So in the first radius, that first cylinder, we're talking about a skinny cylinder, and we're going to find out that it's going to be pretty tall. Well, let's go ahead and find out how tall. H equals, just using our formula, 375 minus 2 pi r squared, but what's r?
2.
R is 2. Over 2 pi r, but what's r?
2.
2.
That's our formula?
We derived that formula right here. So now we're,
Yeah, I get that.
yep, so we subbed in the radius of 2.
Whenever we're working on like other problems, let's just say I have, they give me like 52, then do I put 52 in?
Like a radius of 52?
I don't know.
Or a surface area of 52.
Where are you getting this 375 from?
375 is the surface area
If
right
you divide
here.
a surface area of 15, do I put 15 there?
Right
and
there.
And solve the question?
Yep.
Okay.
Okay, that's what your practice problems will help you do. And we're going to do it a bunch of times now. Okay, simplifying this is pretty straightforward. 375 is still 375. Here, we start with our brackets and our exponent. So 2 squared is,
4,
times 2 is
8,
8. With your calculator out, 8 pi is
25.
let's just stick with whole numbers for now. And down in the bottom, 2 times 2 is 4 pi is
12.5
sure, let's go 12.5. What does it actually round to?
6.
Okay, 12.6. Good. And that you can do in your calculator. 375 minus 25 is 350. 350 divided by 12.6. Calculators.
27.7777777.
27.78. Okay? That is the height of the cylinder with a radius of 2. So go ahead and fill that in your chart. Okay? Height of the radius with the cylinder with a 2. Okay, let's go to the next height. This time we have a 3 centimeter radius. H equals 375 minus 2 pi r, but r is
2.
The radius,
3.
2.
Okay.
This time the radius is going to be 3.
And the height, no, what's the height for the other one?
Right there.
2.
27.
That's for one.
27.8.
What's the volume?
We didn't calculate the volume. We're doing all the heights. Here we go. The height of the second one has a radius of 3, so plug in 3 wherever you see r. You got 2 pi times 3 in the denominator. So 375 minus, what's 3 squared?
9.
Times 2?
18.
What's 18 pi? Calculators. Ronnie, where's your calculator?
56.5.
Okay, so 57, good enough. And in the bottom, 2 times 3 is? 6 pi is?
18.
And 375 minus 57?
322.
Did you do it in your calculator?
No.
Do it in your calculator, because then all you have to do is hit divide by 18.8.
318. 16.9. Yep.
Alright, so our radius went up by 1 centimeter. What happened to our height? It dropped by over 10 centimeters. Assuming we did that right. Okay, let's do one more together. Height equals 375 minus 2 pi r. What's r in our next scenario? 4 squared over 2 pi r, which is now 4. So we need 4 squared
16.
times 2,
32.
32 times pi,
100.53.
100.5, over 2 times 4,
8.
8 pi.
25.
25.1.
Alright, 375 minus 100.5. Cubs, where is your calculator? Punch them in, man.
177.
Divided by 25.1.
10.9.
Okay, so when the radius is 4, the height is 10.9. When the radius is 3, the height is 16.9. When the radius is 2, the height is 27.8. And actually, we're going to do the last one as well, the radius of 5. Here we go, really fast.
By yourself?
Go for it by yourself, sure. And then check the board to see how you've done. Okay, what is your final answer for the height here?
6.9.
6.9 centimeters. Good. So when a radius is 5, the height is 6.9 centimeters. Now, is your chart all filled in?
No, we need volume.
No, we need volume.
Okay, so let's go ahead and calculate the volume of each of these cylinders. Now, what is the formula for the volume of a cylinder?
V equals
The same as for a prism. It's
pi r2 times h.
it's the area of the base times the height. Okay? Which is 2 pi r h. So here we go. Okay, here we go. The volume of a cylinder is the area of the base times its height. So the base is a circle. That's pi r squared. And then times by its height. So let's go. The volume of the cylinder where the radius was 2, I'm going to call it V2. It's pi r squared h. Sub in what we know. R is 2. And h was
27.78.
27.8.
I got the same answer.
So 2 squared is 4. Yeah, it will be the same on this one. 2 squared is 4 times 27.8 times pi.
349.09.
349.1 cubic centimeters. Alright, let's go to the volume of the cylinder with a radius of 3. We've got pi r squared h. This time we know r is 3. And square that, and what's the height?
16.9.
16.9. So we got 3 squared is 9 times 16.9 times pi.
477.83.
Alright, this is what's supposed to happen. And we're looking at centimeters cubed. Volume 4. Pi r squared h. Here we know the radius is 4, so we're going to 4 squared times the height. The height was 6.9 on this one. Oh no, 10.9.
547.89.
What's happening?
They're
It's
getting
going
bigger.
up.
Greater volume, even though they have the exact same surface area.
Is bigger volume better?
It's more efficient if you can use the exact same amount of material. They'll package more in it. More efficient. Alright, fifth volume.
Wait, this be by every time we go up, like the next volume, are we making the object fatter and smaller, or skinnier and larger?
This first one with a radius of 2 has a height of 27. This next one has a radius of 3 and a height of 16. Right?
It went down.
So
This
then
next
we're
one
getting-
has a
we're
radius
getting
of
fatter.
4 and only a height of 10. This one is, the fifth one is going to have a radius of
Smaller.
5
It's smaller.
and it's going to be shorter.
Yes, sir.
It's 541.
Sorry, what was the height? 6.9?
6.9. 541.92.
Alright. Let's take a look at what happened. So as we got fatter and shorter, our volume increased until we reached a certain point,
The pop can is.
then it went down again. Okay, so here the radius is getting really close to the height, and that's not as good. But here where the radius is 4 and the height is 11, that one was our best. I wonder if there's something in between 4 and 5, like 4.5 or something, that would be even better. Okay, I don't know if we've gotten the max, but we've noticed that there is somewhere in between that is the most efficient volume. I'm going to try and really quick do the example here. Okay, go to the example. I'm going to go really fast. Maximize the volume of a cylinder. Determine the dimensions of a cylinder with a maximum volume that can be made with 600 centimeters squared of aluminum. So our surface area is 600 centimeters squared. Okay, and we want to find the dimensions. So we want to find the radius and the height of the maximum volume. And actually, what we needed to learn is that the cylinder with max volume and given surface area, so that's what we're trying to figure out. We're given a surface area and we want to find max volume. The cylinder with max volume and given surface area has height equal to its diameter, or h equals 2r. Okay, so in our last example we had a radius of 4 and a height of 11 was the closest we got to this relationship. Okay, so here we go. The 4.5 is probably better, right?
It's 4.5 times 11, which is
Wouldn't be times 11 though.
what would it be?
It'd be less height. It'd be like 4.5 times 9.5 or something like that. Anyway, you'd have to figure that out using the formula that we used. So here we go. We know that this is true. H equals 2r. So we're going to take our surface area formula for a cylinder, which is 2 pi r squared. So that's the area of both the bases, plus 2 pi r h, which is the area of the rectangular wrap. And we're going to sub in 2r wherever we see h. We just straight up sub in h equals 2r. Now we can rearrange this formula, simplify it a little bit. The first part stays the same, 2 pi r squared. But now we have 2 times 2, which is 4. And we have pi. Maximize the area of a cylinder. Look what happened. We have 2 pi r squared and 4 pi r squared. So how many pi r squareds do we have?
Two sets of 2, so it would be 4.
6.
We have 2 here and 4 here. 2 plus 4 is 6. Okay? Use this formula to find the radius that will maximize volume. So now we get back to our specific example. Okay, we're determining the dimension of the cylinder with max volume that can be made with 600 squared centimeters of aluminum. So we have a set surface area, and we need to determine the dimensions of the cylinder to maximize the volume. So we can use this formula that we just found out. SA equals 6 pi r squared. We know our surface area. We can sub that in. 600. We're given 600 squared centimeters of aluminum to make this can. And if we perform some simple algebra on this, we will be able to determine the radius of the can that will have the maximum volume. Okay? And then we'll be able to also calculate the height. So here we go. A little bit of algebra. How do I strip things away from r, or in this case, r squared? Right? Right. Well, let's do it in the right order. Bed mass backwards. So right now, r squared is being multiplied by 6 pi. So that means I can divide both sides by 6 pi. Okay? I divide this side by 6 pi. I have to do the same thing to the left. If you're still confused on this, you've been wasting your time. You need to go back and study or ask for help at lunch. If you just said, huh, or what, or I didn't know that, okay, this, you know. If you don't know, you will fail your exam.
No, I know, but why would you separate?
Okay, here we go.
Squared?
Let's divide both sides by 6 pi. If I do that on this side, it's really easy to see. They're just going to cancel out, leaving me with r squared, which is good because that's what I'm trying to find out. I'm trying to strip things away from r squared to determine what its value is. Okay? This, I'm not going to overly simplify this, guys. I'm going to leave it in exact units. So what I'm actually going to do is I'm only going to divide top and bottom by 6, and then I'm going to leave it as a numerator over pi. So 600 divided by 6. 100. So in the top, I'm just going to have 100, and down here the 6 will be gone. So now I have 100 over pi. Alright, how do I get r by itself? And if I square root one side, I have to square root the other side. Okay? I'm also going to switch and put r on my left so that it's nice and clean. And we're going to take the square root, and actually you guys know some square root rules. This actually, if I take it out over here, just a little side note, this is actually the square root of 100 over the square root of pi. The square root of 100 is just 10, right? So you have 10 over the square root of pi, 10 divided by the square root of pi, and it ends up being approximately 5.64. Okay?
And how are we supposed to do that?
He's telling you.
You do this in your calculator. Square root of 100.
Square root, like, can you do 100 divided by pi?
You could do 100 divided by pi, and then you could hit square root, second function, answer, enter. Okay? Point is, the radius of this can is 5.64. What's significant about this radius again?
That it's like times its height or whatever.
Okay, so I can find the height of the can now, yeah, but why is the radius this and not 5 or 6 or 4 or 3?
Then you can find out where it's at.
Divide it.
It's approximately.
What was our goal to find out?
Radius.
What I could have picked any radius and I'd have a cylinder. So what's significant
We need to find out
about
the
this
maximum
radius?
volume.
This radius will maximize the volume of the can. Excellent. Good. H, remember, equals 2r. If it says find the dimensions, you need to find r and h. So we just sub in what we know. R is 2.64. So the height of this can is 11.28. And we can add that we're dealing in centimeters here. We don't necessarily need to because we're going to add a sentence. The radius of the cylinder is 5.64 centimeters, and the height is 11.28 centimeters. These dimensions will maximize the volume of the can. Alright, so that's what we did, and we rounded to the nearest hundredth of a centimeter, so that means 2 decimal places, and that's A. So now we'll look over here for B.
That was A.
That was A.
That was just it.
Oops.
All we did was get the dimensions of the can, R and H. Took 2 steps to get R, 1 step to get H, and then a sentence. B, what is the volume of this cylinder? So now we know the surface area. We used the surface area to find the radius and the height. Now it's asking what the volume of the cylinder is. So we look at our formula sheet. We get the volume formula for a cylinder. Does anyone know it off the top of their head? Or know how to get the volume of a cylinder? It's very similar to the one for a prism.
Equals
One
pi
third
R2
pi r
the height.
squared.
So it's the area of the base times the height. Okay, so the area of the base is pi r squared, and the height is h. And we know all these things, so we just sub them in. R is 5.64, which is going to be squared, and then we're going to times it by h. Now, what part of this equation are we going to do first for finding the volume? And we're using our order of operations.
Then that's backwards.
Oh, you do explain.
So we're going to use bedmass, the proper, like, front to back, B-E-D, yep. So we're doing whatever's in brackets first. Well, they're already simplified, but I have an exponent here. So I need to do 5.64 squared,
Why are you doing bedmath normal math?
Yeah.
because I'm not solving for a missing variable.
Oh.
I'm just calculating. All these are just numbers.
Yeah.
5.64 squared. Everyone should have their calculator doing it. Times 11.28
I just did all 10.
and times pi.
1,127.
So in here we're going to round to the nearest cubic centimeter. So we've got 1,127 centimeters cubed. And we finish it off with a short sentence. The volume of this cylinder is 1,127 cubic centimeters, or centimeters cubed. Alright, there you have your example. We've worked through it and talked through it a couple different times. Your homework problems are going to break it down into sections. So for the first one, all you're doing is finding the height of each each cylinder, okay? And the next one, you're arranging them from greatest to least volume, okay? And the next one, you are, again, ordering them from greatest to least volume just by looking at them, by looking at the pictures. And the last one, you get to find the radius and height of the cylinder with the maximum volume given the surface area. So that's not even the part B of our example, that's just part A, okay?